The UK imports over 2 million tonnes of soya a year from the Americas, mainly to be used in animal feed as a high-protein source within a pig or chicken's diet. Some of this soya has been linked to deforested land and turns rainforest from this to this, fueling biodiversity loss and climate change. I'm Sam Ward and I've spent the summer researching insect protein to see if this can be a viable alternative to soya used in pig and poultry diets. So here's a very brief snapshot of my studies. So I'm just about to leave the farm for Heathrow to go off to Munich and do a 3-day tour of Europe looking at insect farming. So just had a chance for a quick stop and amazed at the amount of maize that's grown in Germany, obviously biogas capital of Europe, and interested just to see what sort of tonnage of frass comes out of the insects, and obviously if this can be used as a byproduct to put in the AD plant as well. So we're about an hour east of Munich. So we've arrived at Farm Insect. What's interesting at the minute is this place is literally in the middle of a village. So, the concerns of ammonia emissions, smell, and things like that of producing, a large quantity of larvae is, they're obviously managing the process very well. And wow.
So quite small.
Tiny.
Very tiny.
How old? So how old since these have?
So these must be like something like 5 to 7 days old, like at least.
Farm Insect have proved to me that the black soldier fly larvae can be grown at scale. Some of the robotic automation of the tray and feed handling systems that I saw makes this possible. Individual plants are already in operation in the EU, are producing tonnages of over 60,000 tonnes of larvae protein per year, and so the UK really needs to catch up. So this is the frass. For every 1 tonne of insect larvae you sieve out, there is approximately 0.8 tonnes of frass available as a byproduct. This can be used as a fertiliser or can be used in an AD plant to make green energy, before then still being used as a fertiliser. So the end of our tour at day 1 of insects, we've obviously seen the larvae being grown in the insect chambers. Unfortunately, we didn't get to see any of the actual breeding, which is on the 2nd floor. Amazing building. I mean, it looks like a house in the middle of a village. I mean, they're even you can see here growing tomatoes up the side of the wall. The growth rates of the insects was phenomenal. The feedstock that they use, how it was all automated, looking at the robots, it really shows that there's the opportunity here for real sustainable intensification of food production, really. So just about to board the next plane to Amsterdam. The conditions required to grow black soldier fly larvae are very specific, and one of the major operating costs and sustainability challenges to insect production is energy use. Insect growing rooms are kept at 30 degrees and therefore require a lot of heat. To remain sustainable, renewable sources of energy like anaerobic digestion should be used in conjunction with heat recovery. I've come to InnoPlus to find out how they deal with this issue. InnoPlus use heat recovery systems. They capture the extracted air from the rooms and use this to heat hot water. The hot water is then pumped back around the younger growing rooms to heat them. This can also be used to cool the rooms in warmer climates. Depending on the feed substrate used to feed the insect larvae, large amounts of ammonia can also be emitted. InnoPlus supply ammonia scrubbers to deal with this problem. You can see here the ammonia being cleaned out of the air by being trapped in the water. InnoPlus build and ship ammonia scrubbers worldwide and have designed ways to integrate them into buildings. Day 3, and I've come to see Bob at Insect Engineers. Bob has a different concept to many in the insect industry, as he does not use any trays to grow the larvae, but uses much larger racking belts Bob calls zoom racks. These make the capital requirements when scaling a project lower, as you don't need robotics to handle trays. I saw the breeding side of black soldier fly production, and this presented more challenges of additional processes to harvest and grow the black soldier fly eggs. Bob was very open and showed us around his insect school he has built to run trials and increase knowledge and collaboration in the industry and wider public. I'm home from my EU tour and I've had time to draw some conclusions from my trip. But first I want to thank Thomas, Simon, Julius and Bob for hosting me, and also the Farmers Club Charitable Trust for providing the funding. I've learnt that insect protein production can be done at scale and therefore have a meaningful impact on UK soy usage. Is this more sustainable than soy production? Yes, but it's important to use a renewable energy source and to also use a waste or industry byproduct to feed the larvae. It certainly requires far less land than soya. I found many challenges with the process, like feedstock choice, skilled labour, energy use, ammonia creation, and very high startup costs. All these challenges, though, seem to have answers, and I am therefore very optimistic about this industry's future. It is not currently cost competitive with soya. However, I hope this cost of production will come down in the future once the industry establishes itself. To me, there is a pathway to more sustainable livestock, pig and poultry production, and insect farming is a key step in that path.